For more than a decade, some of the biggest telescopes on Earth pointed at one faint point of light and saw nothing. Astronomers aimed multimeter ground observatories at a single star system for an entire night, straining to pull a spectrum out of the dark. And they failed. Then the James Webb Space Telescope looked for 2 hours and succeeded. That's not a slight exaggeration for effect. That's a direct quote from the scientist who did it. So what changed? And what were they even looking for? Let's go back to 2013, when astronomers first imaged a planetary mass companion orbiting a Sun-like star 57 light-years from Earth. In the constellation Virgo, formerly catalogued as GJ504b. The original discovery images came from the Subaru telescope in Hawaii, a composite of 2 near-infrared exposures, one in orange light taken in May 2011, one in blue light taken in April 2012, painstakingly processed to strip away the glare of the parent star. What was left was a single dim point of light, tinted magenta, sitting apart from its star. That pinprick made headlines almost instantly because of its color. Astronomers said that up close, if human eyes could survive the trip, the world would appear a dark, dusty magenta. Not a rendered photograph, but an inference from infrared data about what its cloud-thin atmosphere would actually look like. Official NASA illustrations later rendered it as a smooth gas giant sphere, a dull cherry blossom pink, similar in shape and scale to Jupiter but noticeably redder, with a radius a little larger than Jupiter's and almost no visible banding, because back then its atmosphere seemed to have far fewer clouds than other directly imaged planets. The nickname stuck: the pink planet. But nicknames are easier than answers. Here's the first problem. At roughly 25 times the mass of Jupiter, GJ504b sits right on the blurry line between a giant planet and a brown dwarf, what astronomers now more cautiously call a planetary mass companion. A brown dwarf is sometimes described as a failed star, an object that formed like a star, collapsing out of gas and dust, but never got massive enough to ignite fusion. A planet, by contrast, is thought to build up gradually, core first, gas later. GJ504b sits close enough to that fuzzy boundary that scientists still aren't certain which one it actually is. Then there's the temperature. Most directly imaged exoplanets run scorching hot, somewhere between 1,000 and 2,000 degrees Fahrenheit. GJ504b, by comparison, runs around 550 degrees Fahrenheit, about 290 Celsius. That's roughly the temperature inside a bread baking oven. Startlingly mild for a world glowing pink in infrared light 57 light-years away. And then there's the age problem, which is stranger still. The star it orbits, GJ504, is comparatively young, only around 160 million years old. But the planet circling it has been estimated, from its properties, at somewhere between 2.5 and 4 billion years old. A planet that appears billions of years older than its own star. That single number is the clearest sign that something about this object doesn't fit the standard story. This is where the new study comes in. Published in July 2026 in the Astronomical Journal, led by Anish Baburaj at Northwestern University, the research team pointed JWST's NIMR spec instrument at GJ504b and, in about 2 hours of observing time, pulled out a spectrum that ground-based telescopes had failed to capture across entire nights. Part of the reason was a new technique, the first successful use of angular differential imaging combined with NIR-SPEC's integral field unit, a star subtraction method that lets astronomers cancel out the glare of the host star far more precisely than before. It's not just a discovery about one planet, it's a new tool other astronomers can now use on other faint companions. What did that spectrum reveal? Water vapor, carbon monoxide, methane, carbon dioxide, ammonia, hydrogen sulfide, even rarer isotope-bearing versions of carbon monoxide detectable for the first time. And crucially, the data showed direct evidence of salt clouds encircling the planet, confirming a theoretical model that had been proposed more than 15 years earlier but never actually observed. The uniform, nearly bandless dusty rose globe astronomers had imagined in 2013 turns out to have real weather in its atmosphere, in the form of these salt-based clouds drifting through it. But here's the twist that makes this more than a tidy confirmation. JWST also found the atmosphere loaded with heavy elements, carbon and oxygen in unusually high concentration, mirroring the enrichment seen in Jupiter and Saturn. That kind of enrichment fits core accretion, the planet-style birth process where a solid core forms first and gathers gas around it. That should mean it's a planet after all. Except the team is careful to caution that brown dwarf formation pathways can, in some models, produce very similar chemical signatures. So the spectrum answers one question and reopens another. Solving the atmosphere didn't solve the identity. So where does that leave the pink planet? We now know for the first time precisely what's floating in its skies. Salt clouds, methane, ammonia, water vapor, a chemistry richer than almost any other directly imaged world. We know a groundbreaking new imaging technique can pull a spectrum from a target that once defeated a full night on the world's largest telescopes. What we still don't know is what GJ 504b actually is. A true planet built the way Jupiter was built, or a brown dwarf wearing a planet's disguise sitting on a boundary astronomers haven't fully drawn yet. 57 light-years away, a dusty magenta world that shouldn't be as old as it appears keeps its final secret a little longer. If you want another cosmic puzzle like this one, the next episode in this series digs into a different distant world hiding an even stranger contradiction. Stick around for that one.